Okay, most of what we're going to be doing today, of course it's not working, is going to be on the computer. So if I can get the computer to actually show, we will be in good shape. Yeah, there we go. Okay, now we're in business. Okay, so real quick, couple of housekeeping things, just real fast. Where did I put? Oh, I'll put it over there. Oh, Lord. I thought I already clicked on this to open. But you know how that goes. Or what's the old saying, you know what happens when you assume? All right. So first order of business. Don't forget that the probability lab is due tomorrow night. Okay? Due tomorrow night by midnight. Lots of examples and pictures and stuff in there to help you. All right, now I was talking about this with my morning class. So we're coming to here pretty soon to the date that is the last date to withdraw yourself from class. We've talked about it extensively. Now, that is next Thursday. Okay, so you don't want to make sure that if there's any class, whether it's this one or another one, that you're looking at and you're like, nah, didn't really go so well this time. I'm going to want to try again in the spring. It's the last day to do that. Also, along those lines, if I withdraw somebody, and I let them know, and then they say, well, is there any way I can get it changed to a student withdrawal? If that happens, that also has to be done by the 9th. Otherwise, it's a no. All right. So just be on top of your grades. Know if you're in danger of that or not. So one of the things that will help prevent this from happening is stuff like this right here. Okay. So far, we've got 3 of the 9 of you that have turned in the answer entry. 2 of the 9 of you that did the work. In a perfect world, those first numbers should match, shouldn't they? They should. Now, this is also why I don't offer extra credit, because I have these. Okay? That's what they're for you to basically double what you got on this by showing your work. Okay? So if you're looking at your point total and it's not where it's supposed to be, this is usually why. Of course, I've also had some folks that have missed tests. Can't really explain that one because tests count more. And that's just across all classes. It's not necessarily in here. But anyway, again, to make sure that you're getting as many points as you possibly can, from here on out, you need to make sure you're doing your work entries because honestly, we're not going to have too many more. Okay, we're a little bit ahead of where we need to be. So, we're not really going to have much opportunity to recoup some points here. All right? So, make sure you're staying on top of things. Due tomorrow night by midnight. I know what tomorrow night is. I do not care. All right? If you want to go out tomorrow night and do whatever it is you're planning on doing, then make sure that you get this done before then. All right? And if it's November 1st and you haven't turned it in, don't send me a Moodle message that says, oh, I'm sorry, I forgot to turn it in. My dog got out, ran down the street. Like, no, I know what last night was. You're hungover. That's why you didn't turn it in. Now, I don't want to say that's everybody, but I mean, we don't all drink like Charlie does. Charlie doesn't drink. No, I was aggravating Charlie. Okay, so make sure you get that done. All right, so today we're going to start looking at Probability and Statistics Lab 3, the statistician. All right, I was running out of fancy name ideas by the time I got to this one. But it is your last critical thinking lab, okay? It's your last one. It's got 2 parts, okay? The main thing that you've got to remember on this lab, okay, you absolutely must remember this. The work entry on this lab is required. You have to do it. And I'll tell you why. Because the questions are split up into two parts. Okay? The first 3 questions, you have to make a scatter plot. Okay? You have to draw it out. Right? You can either do that by printing out the student copy using their provided area and mark your scatter plot in there, or you can draw it on notebook paper if that's easier. I know not everybody has a printer or access to a printer, so if you want to just do it by hand, just do it by hand. The second part is all in the answer entry, and you're just answering scenario questions. Okay, what type of correlation would this situation make? There are not many of them, all right? But you don't need to be starting on this until you finish the one before it. Okay, don't put yourself in a hole. Wednesday, we will be gearing up for the test. The test will open next week. All right. So, and of course, it'll still be online. That should take care of any kind of, testing accommodations that anybody may have. All right. So, you need to make sure, main thing for this Probability and Stats Lab 3, you have to do the work entry. Because 1, 2, and 3 are the only ones that need any work. 4 through the rest of them do not. All right. There is a student copy to see the questions. Again, you can print that out if you want to. Again, a reminder, questions 1 through 3 will be graded in the work. 4 through 12 will be graded in the answer. Okay. So the grades on this one might be a little different. You might get full 50 on the work, and then if you miss 1 or 2 on the answer, it might be a little different. Okay. Now, it also tells you on the work entry how many points each of those 3 scatter plots are worth. They don't all count the same. Okay? Because there's only 3 of them, so you have to kind of skew it a little bit. Okay. So, open the textbook file back up. And what we're going to look at is putting a scatter plot into something like Excel or Google Sheets. This morning at the high school class, we had to do it in Google Sheets because they all had Chromebooks. So, and it worked okay. It worked out fine. Sheets isn't anymore. Sheets isn't all that dissimilar from Excel. Now, if you're on an Apple product, I cannot help you. All right, I don't know how to work them. I'm not even going to try. You're on your own. I am Microsoft and Google. I'm sticking with the mothership. So you should as well. All right, so what I'm going to do is I'm going to try to do a split screen here. Okay, in the textbook file, I need you to, not sure what page this is since I've shrunk it down. Okay, in the textbook, it's page 354. That's the one you're looking for. It's at the end of 5E, the end of 5E. If you're using the bookmarks or the table of contents, it's at the end of 5E. That's where we need to look. All right? Now, the reason why I'm showing you how to do this in Excel, a couple of reasons. One, you can use Excel to check your scatterplot questions and make sure that what you got matches what it should have been. Okay? And we're going to try to do these pretty quickly. Now, how many of you have ever made a graph in Excel before? Oh, God. Okay. Well, this column we don't really need. In fact, we found out this morning that if you put the names in there and highlight that and select it to graph it, it doesn't really make it look like what it's supposed to look like. So we're just going to use these two columns right here, and then any piece of information that we need, we'll just match it to the person. Okay? So let me hop over here. I can do it quicker. So what I would suggest that y'all do as well, okay, we're going to type in the two columns. We're going to type in the home runs and the batting average. And you can just abbreviate it like that. Okay? Let's see. Let me zoom it in a little. Make it a little bit easier to see there. Come on. There we go. All right. So the first one is 41. Then we got 48, 58, 34, 30, 54, 37, 17, 47, 28, 37, 32, 33, 24, 44. All right. Then their companion batting averages. So 330, which, you know, depending on what you've got your cell formatting set to, it'll include the 0 at the end, or it'll kill it. The simplified way is to take it off. So if you want to just leave it that way, you can, or if you want to finagle with it to get it to show it, that's fine too. But it doesn't affect it either way. That's why they tend to drop it. And make sure you're putting them in decimal form. Batting averages are in decimal form. Oh, no. There we go. All right. So we've copied our table. Okay. Didn't take too long. I'm the world's worst when I'm doing these to try to, you know, do it as quickly as possible, and I'll miss a few, or, you know, what usually happens is one column shorter than the other, and I was like, uh-oh, I missed one somewhere. And of course, with me, it's usually somewhere like right in there, and I've got to take them all out and put it in there. That's just, you know, that's just how computer savvy I am. Okay, now to get this to make what we want, highlight, or I guess select, whatever you want to call it, both columns with their headers, the home run and the batting average, okay? Now, I believe the charts are up here in Insert. Yes. All right, so we're going to go here. All right, you see this one right here where it says Insert Scatter? All right, Insert Scatter, X, Y, or bubble chart. And, you know, it's got some disclaimers and stuff there. So click on the down arrow. Okay. It's got a bunch of different ones. Okay. The one we want is this one right here. Just the first one. Just regular scatter. All right. So click on that. Okay. So now, so that we can see this a little bit better, I'm going to put this back on full screen. Okay. And we'll move this over a little bit. Okay. So, not too bad, right? Now, the only thing that kind of looks a little bit weird is this left column over here. All right? Well, hold on. So, like this over here looks a little bit odd. But, I mean, it's our batting averages, so it's got what we need. Now, I will say, one, we'll call it, you know, a leg up that Google Sheets had over Excel, is that Google Sheets put the column headings where they were supposed to go. So, like this one down here across the bottom is your is the homers, all right? And batting average is over here on the left. And the title should really be batting average, or no, that's not right. Come on. should be homers versus batting average. Okay. Now that we've got all that cleared up, is there anything you can see from this? Any kind of conclusions that you can draw about the correlation between the home runs and the batting average of the folks that won the MVPs those years? If you just looked at the graph, what does it look like to you? Yeah, it's pretty flat, isn't it? Yeah, it's pretty flat. I mean, I know that we got a couple of outliers, you know, in a couple of places. But yeah, this for the most part, there really isn't any kind of, you know, distinctive pattern where you can say, oh, okay, well, you know, the more home runs they hit, the higher their batting average is. If you watch the World Series this year, a prime example of this is always Kyle Schwarber for the Phillies. He always hits home runs, but he has to make contact first, and he doesn't always do that. So his homers are going to be pretty high because when he hits it, it's usually gone. But the problem is he doesn't hit it that often. So that's why he would be like, say, maybe Pedroia here. 30 homers, but was batting less than 300. And Schwarber's average isn't even near that high. But, so, yeah, you would say for this one, no correlation. Okay? No correlation. Now, this is also why I don't do the strong and weak negative stuff that the book says. Because, you know, there's someone who's going to look at this and be like, well, there's a little bit of a weak negative at the end of this. And, you know, if you looked right here, yeah, maybe. But the problem I have with that is that's not including everything. Okay, so, yeah. This one will say no correlation. All right. Okay, let's look at another one. All right. Yeesh. Hold on, let's clear this out here. Not the best at Excel. All right. All right, let's do another one. So let's go back to the textbook. Okay. I'm trying to find ones that aren't, you know, don't have like astronomical numbers in them. But it is not making it easy. Okay, easy there. Don't go away. All right, let's look at 27. Following table gives per capita personal income and percent of the population below the poverty level for 10 states in 2010. So let's make a scatter plot out of that and see what happens. Okay. So we will need our columns. So we'll say per capita income and percent below poverty line. Okay, and then we will need to stretch this out a little bit. Trying to do this like with a lag because I'm using the recording screen. So it's basically like a half second behind. Okay, so 43647, 44053, 43721. I know y'all can read. I'm saying these out loud for my benefit. 41156, 44560, 36016, 36964, 45881, 33509, and 33403. Any of those that I messed up? I think they're pretty much okay. All right, then the percent below the poverty line, so 16.3, 12.2, 10, not 103, dear God, 10.3, 10.5, 14.0, which we'll just change to 14, 16.4, 6.6, 10, and 16.9. See, I missed one. Which one did I miss? 14.1. See, I told y'all. I mean, I looked right at you, and I told you. It's usually up towards the top. Okay, so once you got those typed in, double check them. Make sure that they're okay. Mine are now. So we will highlight our information. We're going to go to Insert, and we're going to go over here where all the dots are. Click on it. Click the first option, XY scatter. Oh, what did I do? God, ain't no telling. All right. All right. So that's what that one looks like. I mean, I could see how it would be negative, especially if we were, like if I remembered how to take the first two off of that and start it at 30,000 and stretch it a little bit. I mean, I can also see no correlation, right? That one probably looks more likely because the majority of them, like if you covered up this outlier down here, the majority of them sort of look like they're just kind of bunched up in a square. So if we covered that one up, there's nothing there, is there? No. So that will be no correlation also. Well, that was a waste of time because I was wanting to find one that was a little bit different. But anyway. Yeah, well, let's keep cracking on. All right. So let's go to another one in the book. Okay. Following table gives the average hours of TV watching households in 5 categories of annual income. So there it is. So let's do that. All right. This one won't take long to make. So income, TV out. TV hours. Okay, so the first one, less than $30,000. Second one is $30,000 to $40,000. And we'll give that a little bit wider room there. Then we got $40,000 to $50,000. $50,000 to $60,000. And then greater than 60,000. Then the TV hours, 56.3, 51, 50.5, 49.7, 48.7. All right. Income and TV hours. So there's all that. Highlight it. Insert. XY scatter. Now that one, if we go to full screen here, that one is clearly what? Oh yeah, this one's definitely negative. All right. Yeah. This one is big time negative. All right. Now, as far as drawing conclusions from this, so the bottom is the income in 10,000. All right. The top going across the y-axis is the TV hours. So the hours are over here, and then the income is right there. I don't know why I wrote the R. My brain just went on a vacation. Okay, so then the book wants you to, if you were doing it as book questions, it was going to ask you why this is. Why do you think that the higher incomes have less time spent watching TV? Could be working more, yeah. Could be working later, right? If it's their kids, they could have their kids in more after-school programs because they've got them, they've got a higher income. Could be anything, really. Bottom line is, there's a lot of stuff that's out of our hands. All we know is this is negative, right? Okay, good deal. Clear that out. All right. Well, okay. We'll just do this last one here. Following table gives the average teacher salary and the expenditure on public education per pupil for 10 states in 2010. Okay, so let's get the salaries down first. 47571, 59672, 46952, 64350, 69273, 42964, 55224, 48261, 45,885, and 55,861. Okay, so that was the salaries. Okay, and then was per pupil expenditure, PPE. Okay, so 9,001, 11,000, 6170, 14,472, 14,766, 8,541, 10,476, 9,227, 6,859, 15,345. All right, let's make our graph and see what happened. Go to insert, go to scatter, not pie, scatter. Click the first one. All right. So that one is definitively what? Yeah, that one's positive. Okay? Because as the, can't keep track of my instruments up here. So as the salaries are going up, the per pupil expenditures goes up. If you can afford to pay your teachers more, you can also afford to spend more on the students for stuff they need, right? It basically boils down to, geographical economics. Which we didn't put the states and stuff up there. But, are states spending more than others? Well, yeah, some are. Some are spending a lot more than others on teachers and on equipment and the students. All right. Yeah, so this one is positive. All right. Again, just before I forget, positive means that the data on your x-axis is increasing and so is the data on your y-axis. They are both increasing. Whereas negative means that x is going up, y is going down, and the two that we saw that were no correlation, there's nothing to tell. They're not affecting each other strongly enough to say, okay, this is happening or this is happening. Okay? Now, do you have to make it in Excel for this lab and then somehow get it out of Excel and put it on a piece of paper and upload it to me. No, they're not that involved. Okay, we'll look at it here in a minute, but I was showing you how to do it in Excel so that you can check it. Okay, you can check it and then see if you're close or if you're a little bit far off. All right, so as such, let's look at just the first three on the student copy, wherever it might be. There it is. All right. So let's make this a little bit easier to see. So for number one, if you print this out, like I said, if you print this out, you've got a window to put this in. Okay? So following table gives a total sales and revenue and profit, total sales, which is revenue, and profits for 8 retailers. Total sales is going across the bottom, profits is going up the side. Usually, whenever they give you these tables, your first column is X and your second column is Y. Okay? Usually. So what they've done is they said, okay, we're going to let the total sales be our horizontal or X value, and we're going to let the profits be our Y. So, everybody remember how to mark an ordered pair? X, Y. So you just go to the point, X, Y, mark your point, go to the next one, right? Now you don't have to draw those lines on there. I'm just showing you how you do it. But anyway, easy peasy, okay? So again, if you print it out, put it on there. If you do it on paper, you might just want to copy down what they've got. They've already got it divided up. Should be a lot easier to use. Okay? All right. The next one, though, has a problem. Let me back this out just a hair. Okay. So the table shows the life expectancy at birth for females and per capita gross domestic product for 9 countries. In other words, I think, and somebody that's watching this that actually knows what GDP is will probably tell me I'm wrong, but I think gross domestic product is how much money that country's bringing in off the stuff they sell. Problem. Look at the graph. Okay? If you treat this as X, if you treat this particular question as X and Y and graph it, you will miss it. Because they've got here on the graph their per capita GDP acting as their X. That's supposed to be an X. It's not coming out. And then they've got the life expectancy as Y. So you got a couple of ways to fix this. Okay? First off, what we need to do is recopy that life expectancy column over here. Okay? So just take all that information, throw it over there, okay? Copy it down. Okay? Because now what you can do, once you take all this info and copy it over, you can just kind of mark that out and then relabel, okay, here is X, here is Y. Okay? If you switch those around, you will miss it. Because in the spring, the main reason why people missed number 2 was because, you know, we're accustomed to seeing these tables as, okay, our first one is our horizontal one, our second one's our vertical one. So it's really just an honest mistake because they swapped the axes on the graph and didn't tell us. Okay? Well, actually they did. I take that back. I totally lied. They did tell us right there. GDP on the horizontal and life expectancy on the vertical. Okay? They're checking to see if you know how to fix this. But yeah, take this column, recopy it on the right side, and then just mark it out. Okay? That's whether you print it out or recopy it down on notebook paper. Either one's fine. But you got to fix it. But then number 3 is back to where it should be. Okay? It's got unemployment rate as the X and median rent for the apartment as the Y. That one's okay. So just plot it, and then that's really all you got to do. You don't even have to tell whether it's positive or negative. You just have to graph it. Okay? And then I'll look at the graphs. All right? The last part of your lab for this goes back to questions like I think this is the wrong thing. It goes back to questions like, for Pete's sake, this thing is so hateful. 17 through 24 here that we looked at last week. Okay, you're given situations and you have to tell whether it is a positive, negative, or no correlation. All right. Now on that worksheet, if some of them look familiar to the ones that you're going to see on tonight's work, there's a reason for that. In the question bank for this book, there's really not a lot to put on there pertaining to this. Okay? But 4 through 12, I believe, 4 through 12, there is no work to show. You read the statement, and then you say whether it's positive, negative, or no correlation. Okay? Again, some of these are going to look similar. Just read them very carefully. 10 might cause a little bit of grief. 10 is the actual temperature on a given day during a heat wave and the temperature that had been forecast for that day 10 days previously. All right, so just think about what happens during a heat wave. It should be okay. And then there was another one, which I think it had already showed up once before. Age of a computer and its value. Remember, computers age just like every other appliance. Right? You want a 1-year-old fridge or you want a 15-year-old fridge? Well, it depends on the brand. So that's why it's good for scatter plots, right? Because there's going to be outliers. All right. Any questions? What's due tonight? Probability lab. If you're not one of the handful that's already taken, then that's what you need to be working on. Okay? Not tonight. Tomorrow night. Thank you. Yeah, sorry. Someone's going to hear that online and have a panic attack. No, it's not due tonight. It's due tomorrow night. Tomorrow night. Okay. All right. Any other questions? All right. Then you're good to go.